Alright, so we looked at how to use u substitution to do the integral of 1 over u to u. Alright. But what happens if we have a function like x squared plus x plus 1 over x squared plus 1, where if I tried to make the u the x squared plus 1, there's no way I can get the du in there. Okay? So when you run into a problem like this, basically the strategy that we need to do is to try to divide this out in order to get stuff that we are able to take the integral of. Okay? So we have x squared plus x plus 1. And I'm going to divide that by x squared plus 1. Hopefully we remember how to do our polynomial long division. It's been a little bit. But remember, all we care about are the first two terms. So x squared divided by x squared is what? 1. Alright, now, since that's a constant, put it over the constant right there. Okay? And then multiply it down. 1 times x squared is x squared. 1 times 1 is a 1. There were 0 x's here, if you want to put that in as a placeholder. And now, doing our long division just like we would with numbers, we subtract. So we subtract x squared minus x squared, no x squareds. X minus 0 x's is x. 1 minus 1 is 0. Okay? Now, since what we got here, our remainder has a lower power than what we're dividing by, we can just stop and write that as the remainder, okay? Now when you write it as the remainder, remember you put it over what you were dividing by, okay? So notice what I just did here. I rewrote this whole function so that instead of taking the integral of x squared plus 1 over x squared plus 1 dx, now I'm going to take the integral of 1 plus x over x squared plus 1 dx. Okay? Now, since I did that and I have addition, I can go ahead and do the integral of 1 dx, which is easy. And then I have the integral of x over x squared plus 1 dx. Does everyone understand what I've done so far here? Okay. If you have a rational function and you can't do u substitution, this is what you need to try to do. See if you can divide it out and get something where you can use our rules for integration. So now that you have this, the integral of 1 dx is just x. But then notice here, for this second part, we could make the u the x squared plus 1. It's in the denominator, it's got a higher power. The du is going to be a 2x dx. So I incorporate a 2 here, which means I have to put a half out there. And I can see my du is right here. Okay, it's the 2x dx. So now I'm taking 1/2 times the integral of 1 over u du. Okay? So now it's x plus 1/2. Integral of 1 over u du, we learned in the previous lesson, that's ln of absolute value of u. I want my answer in terms of x. So I have x plus 1/2 ln of the absolute value of x squared plus 1. Oh wait, I don't need dx, I need a plus c. What were you saying, Ryan?
You don't need the absolute value, do you?
Why?
Because it's squared and then plus or positive.
Okay, yeah, and this is where you can simplify a little bit more for yourself. Here, x squared plus 1 is a parabola. It hits the y-axis at 0, 1, and that's the vertex, and it opens upward. That's always positive. So if you want, yes, you can get rid of those absolute value and just put parentheses.
But it doesn't really matter.
And that may make it a little bit easier for you later if you are trying to do some other stuff with this. Okay? One less thing to think about. Okay? So there's our solution. Okay, and that's what we'll do anytime the U substitution won't work. Okay? So let's try a couple more of these. Alright, here we have the higher power on the top. We can't do U substitution, so we do the division. Okay? By the way, remember, there's more than one type of division. You can do the long division, or you can also do the synthetic division. I'm dividing by an x plus 5. Since that's just an x to the first plus a 5, remember we can put the minus 5 in the box and put the coefficients. Here's the x cubed. There's 0x squared minus 6x minus 20. And then when I do the synthetic division, I add straight down and I multiply by the negative 5. I add straight down, I multiply by the negative 5. I add straight down, I multiply by the negative 5. Okay? And then I add straight down, so negative 115. Now, it's important though that you know what this gives you then. Okay? This is then, I lose a power of x, so it's 1x squared minus 5x plus 19 minus 115 over x plus 5.
Can you do that by long division? No.
Yeah, you can do it with long division. You do need to make sure you still put the placeholder in for the 0x squared. Okay? Or else things will get misaligned. But notice now what I'm doing here is I'm taking the integral of x squared minus 5x plus 19 minus 115 over x plus 5.
So now do you just separate them all individually?
You could do them all individually, or you could just do that quadratic, the first three terms you could put together. I mean, you're doing the same thing in your head, even if you don't write it down. But you know this is going to end up being x cubed over 3 minus 5x squared over 2 plus 19x minus 115 times the integral of 1 over x plus 5 dx. Okay? Because the denominator is x plus 5, that's going to be our u.
So ln absolute value of x plus 5.
Yeah, the du is just 1 dx, so it's already there. So now we can get our answer, x cubed over 3 minus 5x squared over 2 plus 19x minus 115 times ln of the absolute value of x plus 5 plus c. Don't forget the plus c. Okay?
So is
Does that make sense?
harder than that?
Huh?
Does it get more confusing than that?
Does it get more confusing than that? I don't know. It depends on if you see it. You know? You just got to look out for it. Anytime you see a rational function, you got to kind of go through these steps in your head,
Like
you
for
know.
number 2, how would you see? Oh, yeah, how would you see that? Because the bottom.
Yeah, what do you think we ought to do with this number 2 here?
Boil it down.
Foil out the bottom,
Bring it up.
you think?
Yeah, that may give you the DU.
Okay, let's give it a try. I'll change colors here. Alright, so you're going to make this the integral of 2x over x squared plus 2x plus 1. So what do you get for the, so you're saying u would then be x squared plus 2x plus 1?
You don't have to do long division for this one. 'Cause
Well-
the bottom's bigger.
Yeah, the bigger power's on the bottom, so we can't do long division.
So this
Du is going to be 2x plus 2 dx.
it's
um,
like a +2.
Yeah, you can't really add a plus 2 in the, I mean, it doesn't really work that way. Let's try not foiling the bottom. What could we let u equal?
Just x plus 1.
Oh, yeah.
Okay? If I made u equal x plus 1, du would equal 1 dx, right? Now, let's think about this. That means that this 2x is still going to be hanging around here, but now we have it over u squared du.
Oh, that makes sense.
So what did we do when we ran into ones like this?
You
We
solve
just
for the x with the u.
We solve for the x with using what u equals, right? So x is u minus 1. Okay? So, think with me here. We've got the integral of 2 times u minus 1, and I'm going to rewrite this as times u to the negative 2 power as well.
I don't. Does this work if you, on the outside, rather than solving for x, could you put a 1 over 2x? Or no?
You can't do it with the variables,
Okay.
only with constants.
Okay.
Yeah. Yeah, if you've got variables in there, you can't pull those out of the integral. So this is how we'd have to handle it. But now notice, especially once I rewrite that as u to the negative 2 and I'm multiplying, I can go ahead and distribute that in. And notice I've got a 2 u to the first times u to the negative second is u to the negative 1 minus 2 times u to the negative second. Okay? Now, what's the integral of u to the negative 1?
2 ln absolute value.
Yeah, ln of absolute value of u. Minus 2 times, what's the integral of u to the negative 2?
Is that
No.
Just use the regular rule.
That's just the power rule, right? It's not negative 1 power, so we can actually just add 1, so it's u to the negative 1 divided by negative 1, right? Don't forget those rules, just because you have, with your negative exponents, that happens all the time. As soon as we learn this rule, we forget the power rule works for other negative exponents, okay? The only time you have to use the ln is when it's to the negative 1 power, okay? So now we go back, we simplify some things, we substitute back in our u, and we get 2 ln of absolute value of x plus 1 minus the negative, so it's going to be a plus 2 over the x plus 1. And then throw on a plus c at the end. And there's our answer. Okay? That's a little nasty, but not too terrible, right? There's an element of flexibility and creativity that you have to have. the more rules we get, the more different strategies we get to do this stuff, the more flexible, the more creative you have to be in order to use them when needed, okay? And by the way, that means you got to really know them well. It's kind of like when you were doing trig proofs. If you didn't have the proofs memorized, you weren't seeing the connections within the equations that you needed to, in order to do the proofs. Here, if you don't know your integration rules and your use substitution strategy really well, you're not going to see those connections that you need to in order to take the next step. All right? All right, so you guys take a couple minutes here and try 3 and 4. Then we'll go over those.
I got my brain.
All right, so for 3, what did you let u equal?
X plus 1.
X plus 1. Okay, so u is x plus 1. So
Du doesn't affect it.
du is just dx, 1 dx, right? So I can swap that right out. So I have the integral of 1 over radical u du. Okay? Now 1 over the square root of u
Is u the negative 1/2.
is u negative 1/2. There we go. Okay? So I'm taking the integral of u to the negative 1/2. So I don't need the ln's in this case. This isn't a negative 1 power. Alright? I add 1 to the exponent. It's u to the half. Divided by 1/2, so it's times 2. Okay, so it's 2 radical u. I plug back in the x plus 1. It's 2 radical x plus 1 plus the c. Okay? So again, just because it's rational doesn't mean we're going to be using ln. We've got to think. Okay? But we do often end up using the u substitution somehow. Okay? How about number 4?
No, it's kind of different. You can use ln.
No, he's not talking about number 3, so let's
Oh, another problem.
do it.
You would make x minus 1.
Okay, u would be x minus 1.
And then you're going to also have to find it in terms of x.
So du is dx, right?
Yeah.
So, yeah, when I substitute in, you know, I'm going to pull the 2 out this time. But I have a u squared on the bottom, and I have the du, but yeah, since we have an x left over, we're going to need to solve this. So that's going to be x equals u plus 1. Okay? So now I have 2 times the integral of u plus 1 over u squared du. And however you think about this one, there's a lot of different ways you could think about it. You can think of this as make that a u to the negative 2 power and distribute it. You can think of it as a u over u squared plus a 1 over u squared because there's only one term in the bottom. Either way, you end up taking the integral of 1 over u plus 1 over u squared. Okay? So now I have 2 times ln of absolute value of u plus, what's the integral of 1 over u squared?
Negative 2u. Or, no, that's wrong. 2 over u. Negative 1 u
It's
to the
Negative
negative
2
1.
over
negative
Negative 1 u to the negative 1.
negative u to the negative 1 over negative 1, right?
Yeah.
Okay, so negative 1 over u is what that would simplify to. Some of you still had the 2's in there, so
I have my
that was fine. I factored the 2 out earlier, but okay. So u to the negative 2, you add 1, it's u to the negative 1 divided by negative 1. So since it's negative 1 power, I pull it down so it's negative 1 over u. Okay, now I do need to plug in the u. So 2 times ln of absolute value of x minus 1 minus 1 over x minus 1 plus the c. You can go further. If I distributed the 2, or if I still had the 2 there, it would be a minus 2 over x minus 1. And if it was 2 times the ln, I could pull that in as a square, and it'd be ln of x minus 1 squared, and I wouldn't need the absolute value anymore. Okay? However you decide to simplify it at that point is up to you, though. Or up to whatever you need it for. Okay? Alright, last example here. Solve the differential equation. Okay? Now, I want you to think with me here, okay? I have dy over dx. I am going to integrate both sides, okay? But before I do that, what I'm going to do is multiply both sides by a dx. Okay? So notice I'm going to have dy equal to 1 over x ln of x dx. And now I can take the integral of both sides. And what's the integral of dy? Y. Okay? Now, the 1 over x ln of x is a little bit interesting. It may be helpful for you to see this, though, as 1 over x times 1 over ln x. And the reason why I say that is because, Nate, what do you make u equal? Okay. If we let u equal ln of x, then the du is 1 over x dx. Okay, so we can see, here's the 1 over x dx. There's our du. Okay? So y, let me get the pen. Y is the integral of 1 over u du. Okay, which is ln of absolute value of u. Well, this is interesting because that means y is the natural log of the absolute value of natural log of x plus c. Okay?
What would that look like?
I don't know what that would look like. You have to graph it or something. Okay. Kind of an interesting looking one. Okay? But that's what y would equal, and then you got the plus c there. Okay? Any questions? Okay. I will say, though, if you have this and you're having to solve the differential equation to get y, okay, don't integrate until after you multiply by the dx, okay? And really what you want to do is you want to isolate the variables. If you had a y on the right-hand side, you would want to get all the y's on one side and dy's, all the x's and dx's on the other side before you integrate, okay? We'll look at that more later, but that is something that you'll want to do, okay?